The topic of today's video will be non-homogeneous linear difference equation with constant coefficients, right? And as you know that a linear difference equation is said to be non-homogeneous if the function present in the right hand side is a non-zero function, right? So I will start writing that general non-homogeneous linear difference equation, and that is of this form. Consider y n plus k plus p1 y n plus k minus 1, right? And this p1 is a constant, right? p2 y n plus k minus 2 up to p n y n pk y n equal to f of n. Let me call it equation number A, right? And the equation corresponding to this given equation, when the right hand side is 0, is called the homogeneous difference equation. If you take the right hand side function as 0 function, so the corresponding homogeneous linear difference equation is yn plus k plus p1 times yn plus k minus 1 plus p2 times yn plus k minus 2 up to pk times yn equal to 0, right? So this is your homogeneous difference equation corresponding to the original equation number A, right? And as we discussed in our last video, that the solution of this equation number B is obtained by writing the auxiliary equation and then finding its roots and then writing the general solution, as we discussed the three cases when we got the distinct roots and equal roots and then complex roots, right? So the solution of this equation number B is already done, right? So let us denote that solution by y n, and we write h here, right? And this h represents for the homogeneous, because this equation number B is the homogeneous difference equation corresponding to this equation number A, right? So this time I will write y n h, right? Because this is just the solution corresponding to the homogeneous part, right? So that's why I have written small h here. Let y n h be the solution of B. And you know that how to obtain the solution of such type of equation when the right hand side is 0. So we denote that solution by y n h, right? Or we can say that this solution is correspond to the homogeneous difference equation, right? Let y n p be the solution for the right hand side term, that is Fn, right? So YNH is the solution, which you already know how to obtain this solution. YNH, right, is a solution for this equation, but YNP is the solution which occurs due to the presence of this right hand side term, that is called separate solution, or we call it particular solution, right? Called particular solution. Right. So the general solution of this equation number A is actually the sum of these solutions, YNH plus YNP, right? Then the complete solution of equation number A, right, is Yn equal to YNH plus YNP, right? So in this video we will be especially focused on finding this YNP, because we already know that how to find this YNH. So our main aim will be to find this particular solution corresponding to the nature of the function present on the right hand side, Fn, right? And again you recall that everything here will be doing will be exactly similar to the theory of differential equations, right? As you know that for a differential equation which is non-homogeneous linear differential equation with constant coefficient, you find the complementary function, which is the solution corresponding to the homogeneous linear differential equation, right? and then you find the particular solution, or you call it particular integral, which corresponds to the solution for the term appearing in the right hand side of the differential equation, right? So same is the theory here, right? And we have several ways to find this particular solution. The first method I will be discussing here is that method of undetermined coefficients, right? So we will be discussing that method, or I will be explaining that method in examples only, right? So I will take the simplest example, and we'll see how we search for this particular solution, right? So to start with, let me take an simplest example, example number 1, and solve y n plus 2 minus 5 y n plus 1 plus 5, or should I write it 6 y n equal to let me write here 1, right? So you can see that this is a non-homogeneous linear difference equation, and see the right hand side is a non-zero, right? But to start with, we will take this left hand side is equal to 0 and find its solution, and that solution will be called as y and h, the solution corresponding to the homogeneous difference equation, right? Solution auxiliary equation, or you call it characteristic equation, right? That will be alpha square minus 5 alpha plus 6 equal to 0, right? And this auxiliary equation is corresponding to the case when the right hand side is 0, right? And how it appears, you should know it, why it is alpha square minus 5 alpha plus 6. The idea is to consider a solution of the type yn equal to alpha to the power n. You should refer to our last video how this characteristic equation or auxiliary equation appeared, right? Okay, so finally I got a quadratic equation, and we know how to find its roots. That will be alpha minus 2 multiplied by alpha minus 3 equal to 0. So I will be getting two distinct roots, one is 2 and another root is 3, and then I will write the homogeneous solution. Therefore yn h equal to c1 times the first root to the power n, and then c2 times 3 to the power n. This is not the complete solution, this is only the half solution. I can call it half solution roughly. Is the solution corresponding to the homogeneous linear differential equation, right? Corresponding to the homogeneous given LDE, right? It means that this is a solution when we consider the right hand side equal to 0, right? Okay, so half of the job is already done, and now we will search the solution for this right hand side term, right? And if you see the right hand side term, this is a constant term, right? There are several techniques actually to find the particular solution. The first one is the method of undetermined coefficient that I will be using now, right? What is that method actually? We just focus on the right hand side, and that is actually 1, right? So since the right hand side is equal to 1 and you focus on this term, this is just a constant, right? So it is natural to imagine that the solution corresponding to this, it means that the particular solution is should be a constant function. Why? Because in order to obtain 1, if I plug that particular solution, whatever is that particular solution, if I plug that here, right, I should get 1, means left hand side should be 1 and right hand side is also 1. So in order to get right hand side equal to 1, left hand side is equal to right hand side, it is natural to take the trial solution as the constant. I will call it trial solution, right? The trial solution, that is a solution that we assume, or we hope that that function is a solution of this thing, right? So I hope that I assume that I will say let the trial solution and the trial solution is actually written after observing this function, right? So I am writing is yn star. This is not particular solution, right? Actually we are seeking the particular solution, right? So to start with, I should take a constant function because right hand side is a constant, so I replace this constant by capital A, right? Had it been n, right? So I have taken here an plus b, right? Had it been n square, so here I would have taken an square plus bn plus c. So the idea is to just replace the right hand side by a trial function, which is the most general, right? If it is a constant, you should take a general constant. If it is a linear function, you should take a linear function an plus b. It is a quadratic n square, right? You should take an square plus bn plus c, right? So this is the idea behind to take this trial solution, right? And this is a very important part of this method. Choosing correct trial solution is very important, otherwise you will not get anything, right? So this is the trial solution. And why I have written this constant, because this was a constant function, so I replaced this by a general constant, that is my capital A, right? And I hope that this is a solution of this particular solution of this difference equation. And now I will plug this here in my equation, right? Substitute it in given non-homogeneous linear differential equation, right? Given equation, I will write that equation, okay? And when I plug this yn star equal to a, this is actually yn plus 2, right? So writing a yn plus 2 star is actually a, because this is a constant, so that will not alter its value a. Then minus 5 times then yn plus 1, again yn plus 1 star will be equal to a, right? So that will be again a, and then plus 6 times of a equal to 1, right? Now you can see that this will give you 2a equal to 1, or then a equal to 1 by 2, right? So this is the constant, a equal to half, so I will put this half here. Therefore now it is confirmed that this is my particular solution. I will replace this star by p, right? So I will put 1 by 2. This is the particular solution, right? And since it is a particular solution and we already had this homogeneous solution, so finally a complete solution will be given by yn equal to ynh. Where is my ynh? This is my ynh. C1 2 to the power n plus C2 3 to the power n plus ynp. So this is your complete solution, right? And remember that if you again recall from the theory of differential equation, this homogeneous solution is when this part only is when substituted in this equation, right? You will get left hand side will be 0. Ultimately left hand side will be 0, right? And when this part, this is called particular solution, is substituted in this difference equation, you will get 1 equal to 1, because this solution, this particular solution, is especially for the right hand side term. And this homogeneous solution is called a complementary function in case of theory of differential equation. Complementary function means is a free function, right? Which is for free, right? So when it is substituted in this equation, it will give 0 equal to 1, right? And that indicates that this solution belongs to the null space. That is called the null space. The solution that is mapped to 0 value, that is called the null solution, right? So in all, this is the complete solution of this difference equation, and you should remember this point, right? Taking a correct trial solution is very important, right? So I will take another example, example number 2, and this time I will change the right hand side only. Solve y n plus 2 and minus 5 times yn plus 1 plus 6 times yn equal to, let me take 2n plus 1 here, right? Or should I write only n? Okay, or should I write 2n, right? So this time I have replaced the right hand side with the linear function, right? So this part will be same. Finding the homogeneous solution will be same, because you can see that the left hand side is precisely the same as we have taken in example number 1. So I will write that directly, right? It's homogeneous solution ynh can be obtained as obtained earlier. That will be C1 2 to the power n and C2 3 to the power n, right, is homogeneous solution. I'm calling it homogeneous solution. However, the correct statement should be that the solution corresponding to the homogeneous linear DE, right? Okay. And now comes the important point, assuming that trial solution, right? Let yn star the trial solution is equal to, and you see the right hand side. The right hand side this time is a linear function, 2n, right? And you should just replace this function by a standard linear function, and that should be an plus b, right? Be the trial solution. And now I will plug this solution in my difference equation. On substitution, in this difference equation, I will have this yn actually, and this yn plus 2 will be a times n plus 2 plus b, right? Yn plus 1 will be equal to a times n plus 1 plus b, right? So a n plus 2 plus b minus 5 times a n plus 1 plus b and plus 6 times a n plus b, and is equal to twice of n, right? Now what I will do, I will just equate the coefficients, right? And before that I have to simplify it, right? You can see that this is an and this is minus 5an and this is 6an, so I can equate the coefficients of n also at this step also. Okay, equate coefficients of n, right? So you watch it very closely. The n first term will be an, so a will be the coefficient, right? And from here you will get minus 5an, so minus 5a will be the another coefficient, and from here you will get 6a, right? And the coefficient of n is actually equal to 2 here, right? So this will give me the value of a, I think 6 plus 1 7 minus 5 2a equal to 1, right? Implies a equal to 1, right? So a is determined, but I need the value of b also, because my trial solution is containing two constants, one is a and another is b. In order to have that b, I should compare the constant terms, right? Because I am getting constant terms also from the left hand side. So equate constants also, right? And you see that the constant term will be 2a plus b, twice of a plus b, and from here I will get minus 5 of a and I think minus 5b, yeah, minus 5b, and from here I will get 6b, and since the right hand side has no constant term, so 0, right? And I know the value of a, right? A is equal to 1, so if a is equal to 1, this will be equal to minus of 3a, and that will appear on the right hand side, that will give me 3, right? I will write that first. 3 will be the number on right hand side, and this is 6b, and then 7b minus 5b, 2b, right? So 2b, and then I will obtain b equal to 3 by 2, right? So I have found the values of a and b, and I will plug those values here in my trial solution, and that will become my particular solution now, right? So therefore ynp equal to, where is that, a times of n, that is n plus 3 by 2, right? And now you can write the complete solution by just adding these two solutions, ynh and ynp. That will be a complete solution, right? Okay, taking another example, example number 3. This time what I will do, I will y n plus 2, the left hand side is still same, 5 times yn plus 1 plus 6 times yn. This time I will take n times okay, 5 to the power n, right? 5 to the power n. This time the right hand side is different, it is n times 5 to the power n, right? So again the homogeneous solution will be the same, C1 2 to the power n plus C2 3 to the power n is homogeneous solution. Okay, that is similar. And now I will take the trial solution. Let the trial solution be yn star, and be careful at this point when you consider the trial solution, right? Okay, and see this is 5 to the power n, okay, that is fine. And see the coefficient of 5 to the power n, that is a linear function, right? So you should replace this n by an plus b, a more general linear polynomial, right? So an plus b multiplied by 5 to the power n. This should be the trial solution corresponding to the right hand side of this difference equation, right? Because the coefficient was a linear polynomial and I replaced this coefficient by a general polynomial, right? Okay, and now I will plug this here. This will give me, on substitution, yeah, a times n plus 2 plus b times 5 to the power n plus 2. This is for the first term, right? You can see, and the second term will produce 5 times yn plus 1, that will become a n plus 1 plus b, and then 5 to the power n is also there. I should write it outside. 5 to the power n plus 1, it will become n plus 1, yeah, n plus 1, and then 6 times yn, 6 times an plus b times 5 to the power n is equal to n times 5 to the power n, right? So this time we are involving a new kind of function, n multiplied by 5 to the power n, right? So be careful while comparing the coefficients of such function, and I should first simplify it because this will become 5 to the power n 5 square, 25 will appear, okay, 25, and I will expand the bracket, that will give me 2a plus b, okay, and yeah, 5 to the power n is also there, right? And this is also 25, and an plus a plus b, and here I will have 5 to the power n, fine, and this will be 6 times an plus b 5 to the power n is equal to n times 5 to the power n, right? Now I will start comparing, right? First I will equate coefficient of, I should equate the constant terms first. Are there any constant terms? No, nothing is constant on the left hand side as well as on the right hand side. So I will start comparing coefficients of n times 5 to the power n, right? So be careful at this point, n times, you see the right hand side, n times 5 to the power n. This is a kind of function. N is a function, n is a polynomial, and 5 to the power n is a kind of exponential function. So the product of two functions is a new function, and that function is precisely n times 5 to the power n, right? So if you focus on the left hand side, the coefficients of n times 5 to the power n will be this term, first term, I think 25a, right? So 25a, and from here I will have yeah, minus 25a. You can see that this is n times 5 to the power n, right? So minus of 25a, and from here I will get 6a, yes, 6a, and right hand side is equal to 1 because the coefficient of n times 5 to the power n is equal to 1. So this term will be cancelled, and that will give you a equal to 1 over 6, right? And now I will equate coefficients of 5 to the power n. Yes, why I am equating the coefficient of 5 to the power n? Because I know that here we don't have any 5 to the power n term. This is n times 5 to the, do not get confused that this is actually n times 5 to the power n. You cannot say that the coefficient of 5 to the power n is n. Coefficient should be a constant, right? So be careful at this point. So first focus on the left hand side. If you see that 5 to the power n is, yeah, this is 25 times 2a plus b is the coefficient of 5 to the power n, right? And from here the coefficient of 5 to the power n should be minus of 25a plus b, yes, and from here we have 6b, right? And be careful at this point, the coefficient of 5 to the power n is 0, right? Do not write n here, right? Because the coefficients should be, all of them should be constant terms. So be careful at this point, this should be 0, right? There is no term of the type 5 to the power n on the right hand side, right? Okay. Now what I will do, I will put the value of a equal to 1 by 6, and that will give me, first I will 50 minus 25, that will produce 25a, and a is actually 1 by 6. 25b minus 25b will be cancelled out, and I will be left with 6b equal to 0. And that will give me the value of b equal to negative of 25 by 36, right? 25 by 36. This is the value of b. And after finding the value of b, a and b, I will write the particular solution, because this was actually my trial solution. Now it is confirmed that it is a solution. After finding the a and b, now it will be particular solution. The value of a is 1 by 6 minus value of b 25 by 36, and then multiplied by 5 to the power n. So this is the particular solution, and then the complete solution will be given by complete solution will be yn equal to ynh plus ynp, right? You can write those two solutions, and on adding them we will get the complete solution, right? Okay, so in all of these three examples, what we saw that we took a trial solution and we just substituted the trial solution, and we were able to find the values of a and b, right? But it is not the case every time. Sometimes you assume a trial solution and you see that that trial solution is not working due to some reason, right? So you have to do some modification in the trial solution, and then you will be able to find the values of a, b and c on substituting it in the given difference equation, right? So sometimes, or what are those cases when we have to modify this trial solution? I will take a few examples for those cases, right? Example number 4. This time I will take the difference equation as y n plus 2, or I should change this, should be yn minus 4 times yn minus 1 plus 4 times yn minus 2 is equal to 2 raised to the power n, right? Okay, and obviously this you can see that the suffixes of this difference equation, this n minus 1 and n minus 2, this is not defined for n equal to 0 or n equal to 1, because if you substitute n equal to 0, you will get a negative index here, and n equal to 1 will also produce a negative index here. So automatically the choice of n should be greater than or equal to 2, right? It means that the values of n are 2, 3, 4, 5, 6, 7 and so on. So far we have done 3 examples where these suffixes were positive, n plus 1, n plus 2, right? So it also can be written in this form, right? But be careful at this point. When you write in negative suffixes, the n should be chosen carefully, right? And now this time I will write the full solution. I will start with that basic thing, that considering a solution of the form alpha to the power n, right? So let yn equal to alpha to the power n be non-trivial solution or non-zero solution, right? Where alpha to the power n is not equal to 0, right? And then and let me call it h, because actually this is done for the homogeneous linear difference equation, right? So I will write h after finding the solution. So when we plug this value here, I will get see this gives alpha to the power n, right, minus 4 alpha to the power n minus 1 plus 4 times alpha to the power n minus 2 is equal to 0, because this thing is done for homogeneous difference equation, right? And you can see that if you take common, alpha to the power n minus 2 should be taken common, because that's the least power of alpha, and inside bracket I will be having alpha square minus 4 alpha plus 4 equal to 0. So this will give you alpha square minus 4 alpha plus 4 equal to 0, as you know that as this term cannot be equal to 0. And why this is not equal to 0? You should know the reason, because alpha to the power n is not equal to 0, right? So that's why it cannot be 0, right? So ultimately we reached here, right? And this is the same characteristic equation which had occurred if the original difference equation would have been yn plus 2 minus 4 times yn plus 1 plus 4 times yn. In that case, the same auxiliary equation or characteristic equation would have been obtained, right? So there is no difference actually. Writing these suffixes in negative terms or n plus 2 or n minus 2, there is no difference. Ultimately, this difference equation would be, this characteristic equation would be same, right? So I will factorize it. I will get alpha minus 2 whole square equal to 0, and that will produce alpha equal to 2 comma 2. So this time I have got repeated roots, and for repeated roots, the homogeneous solution should be written as C1 plus C2n times 2 to the power n is the homogeneous solution, or the solution corresponding to the homogeneous linear difference equation, right? And how it occurred, you please refer to our last video, right? And now comes the important point. You see the right hand side, since the right hand side is actually a 2 to the power n, right? So obviously the first instinct is to consider the trial solution of this form. Let trial solution, what is this? 2 to the power n. If you see its coefficient is 1 and this is constant, so it is natural that you would take a times 2 to the power n, right? Because this is e to the power n is an exponential function, right? And the coefficient of this is 1, and so 1 is a constant, and you should replace that constant by a standard constant, right? So you or should I okay, that's fine. So this, you will take a here, right? But if you plug this value a times 2 to the power n in your difference equation here, you will get 0 is equal to 2 to the power n, right? I can show it. If you plug this here, I will show that. However, this is not correct, but I will show it, right? If you plug this here, what will happen? See, on substituting it, and that will produce yn, that will be a times 2 to the power n minus 4 times a 2 to the power n minus 1, I think, yeah, okay, plus 4 times a 2 to the power n minus 2, and right hand side is equal to 2 to the power n, right? Now what you will do, you will just equate the coefficients of 2 to the power n, obviously. Equate coefficients of 2 raised to the power n, and you see that the coefficient is a here. Here the coefficient of 2 to the power n is 4a upon 2, because it is 2 to the power n minus 1, so it will be 4a over 2, and this is 4a over 2 square, I think, is equal to how much? 1, right? And now, or you should just simplify it, I think. Don't equate the coefficients, right? Okay, a times, that should be taken common, 2 to the power n, and here we have 2 to the power n, right? And you can see that this will give you a, this is actually a plus a, okay, that will give you 0, or 0 equal to 2 to the power n, right? So if you plug this trial solution, which is obviously wrong, here in this difference equation, you are getting something absurd thing. Absurd in the sense because 2 to the power n can never be equal to 0, right? This is an exponential function. Exponential function is not equal to 0. That's why we are getting some absurd relationship on putting this, or on considering this as a trial solution. So it indicates that this trial solution is completely wrong this time. However, this was working in our 3 examples, but this time it is not working. And the reason is that why it is not working this time, because if you see your trial solution, this is a times 2 to the power n, right? And this solution, when substituted in this difference equation, the left hand side is becoming 0. What does it indicate? It indicates that this trial solution should be a part of your homogeneous solution, because homogeneous solution is the only solution which, when substituted in the difference equation, produces 0 on the left hand side, right? So and you can also see that this term c1 times 2 to the power n, this constant times 2 to the power n, is already appearing in your homogeneous solution. So there is no point to consider this solution as a trial solution, right? So we have to do some modification now, because this solution is already appearing here, right? So there is no point to overwrite a solution, This solution is already appearing in the homogeneous solution, so this would not give the value of A, or this would not be the particular solution. We have to do something else, right? So what we'll do, I will put a box here because this is not the correct trial solution, but you should know this why it is not correct, right? Now I am going to do some modification on this trial solution, and how I will modify it, see, then the modified trial solution would be will be surely yn star equal to, if you see this, a times 2 to the power n. And what I will do, I will modify this trial solution. Okay, you see that this 2 to the power n is already appearing here, right? Okay, so I want to create some new solution. This solution, modified solution, should be a new solution independent of that solution, right? So in order to create an independent function, as we discussed in the last video, in order to create an independent solution or function, we should multiply that previous solution by n, right? So what I will do, I will multiply it with n in order to create a new independent solution, right? Different from that, this solution, right? C1 times 2 to the power n. And you see that this is a times n to the constant times n to the power 2 to the n time constant times n times 2 to the power n. But again, this is the part of homogeneous solution. If you focus on the second term, you focus on this term, constant times n times 2 to the power n, it is already appearing here. It indicates that if I plug this trial solution in my difference equation, again the same situation will happen. I will get 0 equal to 2 to the power n, right? So again this will not work due to the fact that this is already present here in the second term, right? So what I will do, I will again modify it. Now I will again try to produce a new solution which should be independent of both of these two solutions. Then I have to multiply again by n, and that will produce an squared this time, right? So this will definitely work, because see this, a times n squared to the power n, this term is not present in this homogeneous solution, right? Okay, so this should be your modified trial solution, and we are hopeful that this will work, right? And I will write the reason why I have taken this, why I have multiplied by n square, right? You should know the reason. And another point of view is that you should multiply the trial solution which is not working actually by n to the power r, right? And what is r? R is actually the multiplicity of your root. If you see here, your root is appearing twice. It means that the multiplicity of the root 2 is 2. It means that r is equal to 2, right? And that's why I multiplied with n to the power r, that is n square, right? Had it occurred 3 times, 2, 2, 2, then I had to multiply this by n cube, right? So the simplest rule is that you just multiply your trial solution that is not working with n to the power r, right? And r is the multiplicity of your root, right? Okay, now I will plug this here in my difference equation. Where is that? In that equation, right? This gives, on substituting here, see the first term, that is yn, will produce a n square 2 to the power n. Second term is 4 times yn minus 1, and that will give you a n minus 1 square 2 to the power n minus 1, plus 4 times a n minus 2 square 2 to the power n minus 2 is equal to 2 to the power n, right? And now we will equate the we have two coefficients actually. One is 2 to the power n, and another will be n times 2 to the power n, and n square times 2 to the power n, right? So for that I have to simplify it a bit. That will produce a n square 2 to the power n, and this will give, I think this will be 2 to the power n by 2, that will be cancelled, minus 2a, minus twice of a, and I will open this, that will give you n square plus 1 minus 2n, right? 2 to the power n, and I think it will become 2 to the power n plus 1, if I'm not wrong. This is 2 square, yeah, 2 to the power n plus 1. I will write that here, 2 to the power n plus 1, right? And for this, 2 square will be cancelled with this thing, and I will be having a times n square plus 4 minus 4n multiplied by 2 to the power n is equal to 2 to the power n, right? Now we will equate the coefficients of like functions. First I will equate the coefficients of 2 to the power n, and those will be from here I will be having 1 and 1. Equate coefficients of 2 to the power n, right? And you should watch it very carefully. That 2 to the power coefficient of 2 to the power n, if you see this term, this should be rejected, because you cannot write a n square as a coefficient of 2 to the power n. You are having a function, right? Coefficient should be a pure constant, right? So here we don't have any 2 to the power n, and if you see here, yes, you have 2 to the power n here. That is 2 times 2 to the power n. That will be 2a times minus 2a, minus of 2a, right? And from here you will be having 4a minus 4a times this, so minus 4a, right, equal to 1, right? And then finding the value of a, this will give you, or a is equal to minus 1 by 6. So this is your a. And similarly, coefficients of n times 2 to the power n, right? We have terms in the left hand side which are containing n times 2 to the power n, and you see that where is that term? This is plus 2 times, not 2, 4 times, this will become 4 times a. If you see this term, you multiply this by this, and then this will give you a plus 4 times a n 2 to the power n, and then coefficient will be 4a, right? And from here you will be getting, I think, this term, minus 4a equal to 0, and that will give you nothing, because 0 equal to 0 will be obtained, right? So already a has been obtained, right? So this is giving you nothing. So I am rubbing it, and I will change the coefficient now. Coefficient of n square 2 to the power n. It will give something. Actually, I need b. A is already found. I need b. So from here the coefficient is a. That is fine. From here the coefficient is, again, there is minus. That is minus of 2a, I think. And from here, sorry, what is my I only needed a, so there is no need to write this, right? A has been found. I was searching for b actually, but b is not there. So I will just put this a here, right? Therefore yn star equal to n square by 6 minus 2 to the power n, right? And this will become your particular solution now, right? Therefore the complete solution is yn equal to ynh plus ynp. This will be your complete solution, right? Taking another example, example number 5. Example number 5, and this time what I will do, I will yn plus 2, I need 2 to the power n, and one root should be minus 5 times yn plus 1 plus 6 times yn equal to 2 to the power n, right? And let me take another term as n, right? So this time we are having 2 terms on the right hand side. One is the exponential kind of function, this is a linear function. So there will be 2 particular solutions, or 2 trial solutions will be constructed for the right hand side. And I will write the homogeneous solution directly, right? Solution. First I will write that auxiliary equation, right? Auxiliary equation will be alpha square minus 5 alpha plus 6 equal to 0, and that will produce alpha equal to 2 and 3 as roots, and therefore your homogeneous solution will be of this form: C1 2 to the power n plus C2 3 to the power n is a homogeneous solution, right? And now focus on the right hand side, right? Now right hand side is 2 to the power n and plus this also. So first I will be taking these two functions separately. The right hand side, the RHS1, right? The first function, that's 2 to the power n, and corresponding to this, the trial solution will be for the right hand side, the first term of right hand side, that's 2 to the power n. The trial solution, let trial solution B, and be careful at this point, you have to consider several facts, right? So yn star, I'm writing yn star equal to, see this function, this is 2 to the power n, and the coefficient is 1, and 1 is a constant, so you should replace that constant by a general constant, that should be a times 2 to the power n, right? And now again comes the same point. What is that? You focus that this is 2 to the power n, actually this 2, this solution is already appearing here, so there is no point putting this solution in this non-homogeneous difference equation, because that will produce 0 equal to some 2 to the power n, that will give some absurd mathematical relationship, as you can see in that example, right? So I have to do modification at this point, right? And you see that this is appearing here, right, once, and again the another point is that actually this is 2 to the power n, and this number is 2, and this 2 is appearing here as a root of this auxiliary equation, and the multiplicity of this root is 1. 2 is appearing just once, so you should multiply this by n to the power 1, right? The golden rule is that you should multiply your trial solution that is not working with n to the power r, where r is the multiplicity of the root. That is the same thing as this number, 2 is the root, right? So I will multiply this by n to the power 1. I'm writing that directly, a times n to the power 1. So my trial solution corresponding to this first function is this one. Now I will see this, right? For right hand side second term, that is n, let trial solution, I will write it yn1, or I will denote it by yn1, okay, fine, yn1, okay. Trial solution B, yn star 2, and that should be, if you see that this is a polynomial, so polynomial should be replaced by a standard polynomial of the same degree, that should be bn plus c, because a has been used, I should write a new constant. And again, do not forget to consider the case, because this is actually nothing, this is n times 1 to the power n, right? 1 to the power n, and you see that 1 to the power n is not appearing in your homogeneous solution, so everything is fine, right? So you need not to modify this trial solution, right? So ultimately my full trial solution will be the sum of these two solutions, right? So therefore yn star becomes the sum of these two functions, a n times 2 to the power n plus bn plus c, right? And then I will plug this value here in my difference equation, right? Substituting in this equation, given equation, right? I will get yn plus 2, that will become a times n plus 2 times 2 to the power n plus 2 plus b n plus 2 plus c, and then minus 5 times a n plus 1, 2 times n plus 1 plus b times n plus 1 plus c, okay, and third term plus 6 times an times 2 to the power n plus bn plus c equal to 2 to the power n plus n, right? So we have a long equation, and we have to compare the like functions very carefully. First I will compare this 2 to the power n, coefficient of 2 to the power n, coefficient of 2 to the power n, right? And if you focus on the left hand side, 2 to the power n, this is 4, 4 to 8a, right? And from here, where is that? Okay, here we don't have any term, right? This is 5 times, I will put here bracket here, this is 5 times, and this will give you 10, yeah, 10a, 10a, if I'm not wrong. It should be 5a, 10a, 10a, yeah, 10, right? And from here nothing, and from here I think no, here will not have any 2 to the power n term, and equal to 1, right? And that will produce a equal to minus 1 by 2, right? And now I will equate the coefficient of n, yeah, coefficient of n, and be careful at this point, you will just pick up the coefficient of n only, right? So there is no term which is containing n, right? You just see it very carefully, right? It will give you n times 2 to the power n, it will give you 2 to the power n term, but n term is missing in this term, right? From here you will have to b, and from here you will obtain, this is not considered, okay, from here you will obtain minus 5b, and from here you will obtain what, 6b, yeah, 6b equal to 1, the coefficient of n is 1, right? And from here I will get b equal to half, I think half. Now it all remains to find constant c. Now should I equate the constant terms? If I equate the constant term, this is c, this is 2b, yeah, equate constants, okay, and from here no constant is there. Here I will be having twice of b plus c, and from here I will be having no term, minus 5b minus 5c, and from here I will be having 6c, I think, yeah, and from right hand side there is no constant, right? Okay, fine. And now I will put these values b and a, and this is 2b minus 5b, that is minus of 3b, minus of 3b, right, these two, and this will give you 6c, 7c plus 2c equal to 0, and that will produce c is equal to 3 by 2 times b, and what is the value of b? 1 by 2, right? So ultimately that will be equal to 3 by 4. So the value of c is 3 by 4, right? And then plugging these values, therefore my trial solution is now particular solution, that is that a times a is half minus half times n times 2 to the power n plus bn, b is actually half n by 2, and plus c is actually 3 by 4. So this is a particular solution, and on adding your homogeneous solution, this one, and particular solution, you will get the complete solution, right? Okay, so I will take last example. In that example, the right hand side would be completely different, right? Okay, so example number 6, yeah, 6. Find the solution of difference equation, and that is yn plus 2 plus yn equal to sine n pi by 2, right? And you can see that the right hand side function is completely different this time. That is a transcendental function, right, sine, okay. And okay, I will start with the auxiliary equation. That should be, if you see that this is a second order difference equation, that will produce alpha square, and be careful at this point, yn plus term is missing, so here I will have 1, yeah, equal to 0, right? So that will produce alpha equal to plus minus iota, or you can write it as 0 plus minus 1 iota. So this is the value of a, and this is the value of b. A is equal to 0 and b equal to 1, because we are getting complex roots, and for complex roots the homogeneous solution is written in this way. We have r to the power n outside, r to the power n, and okay, and inside bracket we have c1 times cos n theta plus c2 times sin n theta, right? And where this r is actually square root of a square plus b square, and that will produce 1, and this theta is actually tan inverse of b upon a, and b is 1 and a is 0, that will produce pi by 2, right? So ultimately your homogeneous solution will be of this form, cos n pi by 2 plus c2 sin n pi by 2, right? And now comes the very important point. Considering the correct trial solution, you see the right hand side, that is sine of n pi by 2, right? So okay, let trial solution be yn star. If you see the right hand side, that is a sine function, and before sine function I have one constant, and that constant should be replaced by some standard constant, a sine n pi by 2, right? That is fine, but that is not complete actually, right? Because another term should be considered, and that term should be b times cos n pi by 2, right? And the reason for adding this term, cos term, is that Actually, these linear difference equation can be considered as differential equations or discrete differential equations, right? If you again recall that theory of differential equation, the idea of considering the trial solution in case of differential equation, when the right hand side is some function, suppose this function is fx. In case of differential equation, x is a variable, independent variable. We consider a trial solution which is actually the linear combination of fx and its derivatives, right? So if we had sin x in the right hand side in case of linear differential equation, then the trial solution was taken in the form of a times sin x plus b times cos x. That's it, because you know that the differentiation of sin x is cos x, and you again go on differentiation, you will again obtain sin x and cos x, right? So the idea is to take the trial solution of the form which is actually the linear combination of the function that appeared in the right hand side and its derivatives, right? And the sine function has a derivative cos, and you again derivative it, you will again get sine, right? So that's why the same theory can be applied here. I'm repeating it because difference equation are just the discrete differential equations. So by the same logic we have this term, right? The first thing is that. But since you can see that here you see that this is a homogeneous solution. This term, you focus on this term, is present here. Yes, it means that we have to do some modification. Again, you see this term, this is also present here. So you have to apply some modification. You have to multiply it with n to the power r, right? So this time I will be multiplying with n to the power 1. Why n to the power 1? Because you can see that this plus minus iota was obtained once, iota and minus iota. The multiplicity of iota is 1, the multiplicity of minus iota is also 1. So I have to modify it by multiplying it with n to the power 1, right? So I am doing it in the same step. It will become a n, and here it will become b n, right? And you should know the reason why this is taken as a modified trial solution, right? And now I plug this here. On substitution in that original difference equation, this will be substituted here. Be careful, right? That will give you a times n plus 2, right, sine n plus 2 pi by 2, okay, plus b times n plus 2 cos n plus 2 pi by 2. This is the first term for this. Then yn is repeated actually. Where should I write that? A n sine n pi by 2 plus b n cos n pi by 2. And then the right hand side is sine n pi by 2, right? And before actually comparing the two sides, you should first simplify this, because this pi by 2 can be taken inside, and that will give you sine pi plus n pi by 2, and that is sine pi plus theta is minus sine theta. So use those trigonometric ratios here. I will rub it first. So that will give you a n plus 2, and this will become sine pi plus n pi by 2. That will be minus of sine n pi by 2, right? So I will put that minus here, sine n pi by 2. And similarly, this will become minus b n plus 2 cos n pi by 2. Okay, that is the first term. Then this one plus this is a n sine n pi by 2 plus b n sine n pi by 2, right? And then equal to sine n pi by 2, right? And now should I simplify it more, because I think this term will be cancelled. If I multiply this, minus n times sine and plus n, that will be cancelled. Minus bn times cos, and those two terms will be cancelled. So ultimately on the left hand side I will be having only two terms, and the terms will be minus of twice of a sine n pi by 2, and from here I will be having minus of twice of the cos n pi by 2 is equal to sine n pi by 2, right? So now I have to equate coefficients of sine and cos, because you can see that the function is sine function. So I will equate the coefficients of sine and cos, equate coefficients of sine n pi by 2 and then cos n pi by 2 one by one, right? So if I equate the coefficients of sine, I will get minus twice of a equal to 1, and if I equate the coefficients of cos, I will get minus twice of b is equal to 0, because there is no cos term in the right hand side. So that will produce a is equal to minus half and b is equal to 0, right? So I will plug these values in the trial solution. Where is that? Here is the trial solution. Therefore the trial solution now becomes the particular solution, and plugging the values of a and b, that will give you minus n by 2 sine n pi by 2 and b is equal to 0. So that's why the cos term will be absent, and this will be a particular solution. Therefore the complete solution will be given by y and h. Where is that y and h? Here is that y and h. C1 cos n pi by 2 plus C2 sine n pi by 2 and plus this particular solution is the complete solution, right? So you have seen that you can use that method of undetermined coefficient. Why we call it undetermined coefficient? Because we actually determine these unknown coefficients a and b in this method after considering a correct choice of trial solution and then plugging it in the non-homogeneous difference equation, right? We can always find a particular solution, and then sum of the homogeneous and particular solution is called the complete solution, right? So this is it for this video. In the next video we will be taking some another method to find this particular solution, that is called the operator method, right? And that should be the part of the next video. For this video, thanks.